Hello everyone! Today I would like to talk about my favorite topic: how to make sure models continue to perform in the future. The reason this is my favorite subject is because it talks about the heart of modeling, the risk of losing money and the risk of model failure. So what is this story? We build a model, it works great on backtesting for a few years, then on real money for a few years, and suddenly it stops working. If it stops working immediately after the initial backtesting, we say that this model is overfitted, meaning that it's fitted only for a backtesting period. And if it working after a period of real trading, such a downturn of results called fading. After fading, the next question always comes up: should we wait out such a period, or is there a chance that the system will start working again? When I was preparing this presentation, I realized that these questions are coming from the fact that stereotypically, models are treated as black boxes, a system which can be viewed in terms of its inputs and outputs without any knowledge of its internal workings. Its implementation is opaque or black. And then yes, for those quant that treat their models as black box systems, and I saw vast variety of such systems and modelers, both overfitting and fading are inevitable death sentences. But not for the true quants. To explain how we at Endotech and other true professional developers are building durable models, I decided to look for a good analogy on the subject, whether modeling of markets for trading is a science, business, art, and I found the best analogy in sports. Trading is a zero-sum game. There are winners and there are losers. We need to train your models on the past, and then models compete. Sports results improve, new participants come out better, stronger, faster, and you need to continuously train your models to be able to compete. There are lots of external reasons at each competition that affect the competition. So let's dive into how we at Endotech approach the question of making sure that our models are durable. First, we model different behaviors of the market. We distinguish 8 market states. Now, each time of market demands a different skill set from the model. Elite slalom skiers are most likely to lose in tennis to mediocre tennis players. As there is no such thing as a universal athlete, it is also very hard to build a universal model. Our school of modeling says, given the market season, develop the best sportsman, meaning giving our model the skill set required for such specific market pattern. Define at each training sessions goals to reach, such as far away jump as possible for bearish trends, the correct response to sideways swings, and so on. Then, we need to find a way to identify the seasons. Here comes a very handy concept: filter. You trade only during the seasons that you find easy to identify and have a good model trained for it. Our logic works as follows. As in real seasons, you find it possible to distinguish winter from spring by checking average temperature and natural biological clock. Same for markets. We can fairly easily distinguish a bearish market from bullish using moving averages and volatility indicators. But what if we are late or too early with our predictions? This is another skill set that we have in our system: filter building or meteorology. Again, the main idea in trading is, if you cannot do something, just don't do it. No sport pun intended. In crypto, there is a very consistent switch between seasons with rare changes in the patterns. Bullish moves are followed by short-term bearish reversals, then sideways market, and then bullish trends again. After several bullish trend cycles, you can see a strong corrective bearish season. In Forex, for example, depending on the time frame, some seasons are underrepresented, such as smooth bearish or bullish trends. And even if we get into them, simple stop loss or time-based stop takes us out safely. The only true turmoil for the model is the new players that come to the market and change market dynamics. It might take time for developers to understand it, or even more importantly, to accept it. When new significant players enter the market, they can change the way market moves and reacts in both macro and micro schemes. At Endotech, we have developed a few markers that are responsible for identifying market style. It includes volume changes, rate of change, first, second, and third differential functions on each time frame and element, as well as statistical prediction for each price pattern. Once it starts to change, we downsize the portfolio allocation into models in this market. And again, our mantra, in case of lack of clarity, just do nothing. But sometimes you might decide that all your model needs is to learn a new trick. And here comes my second favorite topic, overfitting. Imagine your elite skier have trouble performing during a foggy winter. So you decide to spend a year to train him on this certain skill. But next winter is a crispy clear and icy. So an athlete falls short in these new conditions. Overfitting means over-specialization. On the other hand, you need to train your models the way elite athletes are trained now by using advanced technology to help them understand small differences and small issues. For example, a tennis racket for Federer is completely different from another athlete because it's calculated according to the details of their physique and the length of their hand and so on. Many things are taken into account. To escape overfitting, we use a holistic approach. We try to reach multiple goal functions. It means that we are building a model where it's trained for every situation and generally makes durable and robust model for this market. We will discuss technological aspects of the optimization in our next sessions. As taking care of multiple goal functions with a set of constraints, it's not an easy computational task. I hope you got the picture why it's usually hard for model developers to design models that are not fading. Specifically, if a developer is only using a complete black box approach and tries to solve all questions at once. Most probably he or she won't be able to design a universal model that works in all market conditions. And while conditions remain the same, he or she will be happy with the performance. But once performance starts to decline, they won't have a clear answer on why it happened and whether the optimal time for their model will come back again. Let's summarize. Our models are elite athletes that compete with other models in the market. We have different seasons and we need as many models. We need filters to define the seasons. And we know how not to let our model overfit and to be optimized and trained each day. Next time, we will discover the most frequently asked question of the model developer. Bye for now and see you next time.